In this module, you'll learn to use joints to position components and to use as-built joints on position components. In Fusion 360's design workspace, you can create assembly joints between components in an assembly. A joint is a mechanical relationship that defines the relative position and motion between two Fusion 360 components or subassemblies. In the demo file, you'll see the main assembly includes an external component. The external component includes a tea kettle base and wooden handle. The main assembly includes a lid component and the knob for the lid, each of which is currently not in the correct position. Without joints applied, you can drag components freely. The first consideration with assemblies is choosing which component to ground. Grounding a component will lock it in place, allowing us to define joints for the remaining parts. Generally, it's best to ground the component that touches the ground or a component that many parts will be assembled to and will not move. In the Assemble dropdown of the toolbar, we'll find two different types of joints. The Standard Joint tool creates a joint between components that are not yet in their desired position. Conversely, as-built joints create a joint between components that are already in their correct position. Using an as-built joint, we can ground the tea kettle base to the origin of the top-level assembly. Once active, we can select the two components that we would like to join together. In this case, the tea kettle base component followed by the root or top-level component. Second, we can see Fusion 360 offers 7 unique joint types. The default of rigid is most popular. Rigid acts as if we were to glue or weld them together. Notice you can also animate the joint to ensure the joint type and motion are working. If we now click and drag the tea kettle base component, we'll see that it no longer moves. We can now use joints to set the position and movement for each remaining component. For example, we'll find the wooden handle can still move. Because it's resting in the desired position, we can once again use an as-built joint. Once active, we can select the wooden handle and the main tea kettle body. Let's click OK to confirm the joint. If we now try to move the wooden handle, we'll find it's locked in place. The rigid joint, which is parametric and recorded in the timeline, will prevent the handle from ever moving unless we change the joint type or remove the joint. Fusion 360's joints reduce the complexity of component relationships by helping you focus on what components can do instead of what they can't. Joints differ from traditional CAD approaches like constraints or mates, where you would need to lock down available degrees of freedom. Let's now take a look at the Standard Joint tool. The lid and knob of the tea kettle are not currently in the correct position. Components not yet in position are the right candidate for the Joint tool. Let's hide the tea kettle base and zoom in on the lid and knob. First, we'll use a joint to move the knob to the lid, and we can then move the tea kettle lid into position. Once active, the joint command requires us to define the joint origin. A joint origin defines the geometry to relate two or more components with Fusion 360 joints. With the joint command, it's important to note that the component we select first will move to the second component in the joint animation. The order of selection otherwise doesn't matter. Notice there are a few different mode options to apply the origin. Using the default standard method, we'll hide the lid and zoom into the bottom of the knob. We can see the joint origin icon appear when I hover over the bottom face. This helps us see the relation to the coordinate system, allowing us to apply the second joint origin in the desired orientation. I'd like to select the center of the knob, which will make it easy to align with the center of the lid. However, you'll notice the joint origin may want to snap to many different edges. To avoid this, we'll hold down the Command key on Mac or Control key on Windows, which will lock the selection onto the planar face your mouse is hovering over. We can then move to the center to select it. In the joint dialog, we'll then see we need to select a second joint origin. Let's toggle the lid visibility back on and view the model from the home view. This time, we can select directly in the center of the top of the lid, as that's where the knob would screw into place. Remember to use Command or Control to lock into the face. The two joint origins we selected will now move into alignment, resulting in the knob moving into the correct position. The Joint tool also allows us to select from 7 motion types. I'll double check that this is set to rigid, followed by the OK button. We can now right-click to use the marking menu and repeat joint to reactivate the tool. This time, we'll find the underside of the lid, which will rest on the tea kettle base. While holding the Command or Control key, let's move to the center to set the joint origin. We can then make the tea kettle base visible and select the corresponding top edge. Notice the preview shows the new location of the component. I'd like the vent holes to align with the handle. Fortunately, joints allow us to use the alignment options to define an angle or offset. For example, I'll rotate the viewpoint 90 degrees. Offsets will help us precisely apply joints when we have few faces to reference while creating joints. In the Motion tab, let's review the differences between rigid, revolute, and slider. Notice how each of these will provide different motions and degrees of freedom. Sometimes the joint you apply will depend on the need of the design file. Using the slider option may be necessary to showcase a product animation. I'd like to create a product rendering with the lid in its resting position. I'll leave it set to rigid and then click OK. The tea kettle assembly is now together and all parts are in the correct position. Notice how none of them will move if we attempt to select and drag them. Remember, joints are parametric, which means you can edit them in the timeline or browser and then alter the joint origins or motion. Joint limits, motion links, contact sets, and more advanced features will allow you to define your assembly and how your product works. You've now successfully learned how to apply joints and as-built joints to assemble components in Fusion 360.